For this brain starter, find those 5 values. Well, clearly, 1/10 is 0.1, 1/100th, 0.01, 0.001, 0.0001, and 0.00001. So, the real reason that I included this brain starter is to think about what happens if your denominator keeps getting larger and larger. What value does it start to approach? Or, written another way, what is the limit as x approaches infinity of the function 1 over x? So in this case, as we can see, if we have 10, it's 0.1, then 100 gets a little lower, 1,000 keeps getting lower, 10,000, 100,000. As you keep going to just bigger and bigger values of this, the limit is that this will always approach 0. And you can also see that on a graph. Today we're going to deal with rational limits, so functions that have a polynomial in the numerator and the denominator. We're going to see what happens as those functions approach infinity. So for our rational function here, which is called, in this case, r of x, you have a numerator polynomial, n of x, and a denominator polynomial, d of x. And then there's various rules depending on what the highest power, the degree of the numerator and denominator are. So, for example, if the numerator is less than the denominator, so if the numerator is, say, 5x, and the denominator is 3x squared, then this says that the limit would go to 0. Now let's think about why that is. If you look at the function here, and then really big numbers, like say 100, you would have 100 times 5, and that's 500. It's a very large number. But down here, you would have 100 squared times 3. The point here is that this squared portion makes the denominator grow so much faster than the numerator that essentially what you'd be looking at is some kind of big number on top and some huge number on the bottom, which, as we saw in the brain starter, if the denominator grows rapidly, then the function over time as it approaches infinity goes towards 0. So, now we have a different idea. What if the degree of the numerator equals the degree of the denominator? So for example, what if we had, 6x cubed over 7x cubed? So in this circumstance, they're both cubic functions on the top and the bottom. So when you think about it, these x cubes are going to grow at the exact same rate for larger and larger values of x. So what you want to think about is the ratio of the coefficients. So essentially, as these x cubed become pretty much the same, they will be the same actually, then what happens is it goes in a linear fashion where the ratio is always 6 over 7. So in this case, the actual limit of this function as x approaches infinity would be 6 over 7, or the ratio between the coefficients with the highest degree. And then, the last example, of course, is what if the numerator has a higher degree? So, for example, 6x to the 4th over 9x squared. Now, in this circumstances, I think it's pretty clear to see that since the x to the 4th is going to grow faster than the x squared, this is going to take off and just go huge as the x values approach infinity, while this one will lag behind a little. So essentially what happens is the numerator grows rapidly, and the denominator not as much. So what you're going to have is a really huge number over a relatively small number, which means that it would kind of go towards infinity in this point. So they would say the limit does not exist, because in that case, you would think to yourself that you can't actually pin down a pure number that it would be. This would just go towards positive infinity, or does not exist. Now we have three limits to solve. So, in this first one, 5, you can think of this as 5x to the 0, which means the power of the top is 0, the power of the bottom is 1. Since the power of the bottom is larger than the power of the top, this limit goes to 0. Over here, we have an x squared and an x to the first. That means the power of the top is greater than the power of the bottom, which means this limit does not exist. And here, you'll see that we have x cubed and x cubed, so essentially we can kind of ignore these and then just focus in on this, and our limit as x goes to infinity is just 7/2.